everybody, and we are back on Friday. We're going to be starting our triangle proofs now. So we're going to put to use all those theorems we've been working on: side, 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 angle, side, angle, side, angle, 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 side, and HL, hypotenuse leg. Okay, so first of all, these are some reasons that you're going to kind of need to use, or not reasons, but I guess remember proofs for reasons. As you go through the proofs, these are going to be different ways you can prove angles and sides and so forth congruent. You know, so for sides, there can be congruent. Watch for definitions of midpoint. So if something's a midpoint, it'll create two congruent pieces of that side. Reflexive property is when it shares a side, so it's a side equal to itself. Okay. Definition of a bisector, we kind of talked about that. Same thing as a midpoint. Converse of the base angles. So if you have a base angle of a triangle, that means that the sides of the triangle will be congruent, because that's a converse of the isosceles triangle theorem. Okay. Here's all my reasons for congruent triangles, all listed. Hopefully you have those by now. Reasons for congruent angles will be definition of an angle bisector that will create two congruent smaller angles. Reflexive angles, again, if you have a triangle that shares the same angle in both triangles, that would be the reflexive angle is equal to itself. Vertical angles would be another one. If you have parallel lines anywhere and have alternate interior or exterior angles, even corresponding angles. And then, of course, base angles of an isosceles triangle is congruent as well. There's many other reasons, but these are the main ones we use in geometry, okay? So you might want to either take a picture of this or pause it and write it down, but these are things to kind of remember what you're looking for to find that third side that you might need, okay? So we're going to start constructing proofs. And if you just kind of follow the simple procedure of, we need three parts to show that a triangle is congruent, okay? We need three different parts. It could be a side, 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 a side and an angle on the side, an angle, side, angle, any one of those parts that fit, okay? It could be a hypotenuse leg, so sometimes those three parts would only be two parts because you already have the right angle. Then the fourth thing we're going to prove, they're going to write down here, that's going to be to actually show that our triangles are congruent, okay? And so if you follow those three steps, you should be able to work through this, pretty decently. So the first thing I look for is anything that's given, all right? So I know that BC is congruent to DA, okay? So BC is congruent to DA. And that is a reason that's given to me. It's already stated that, and it's actually already marked up here also. So you can look for statements written out or also marked on the actual figures themselves, okay? We also know that this is going to actually be more than three steps, because we have BC is parallel to AD. So you have to kind of show that. And I should put my segment over there. This is also given, okay? And because these are parallel, this is like a little transversal. If you kind of extend this line, here's my two lines here, my transversals. So I have this angle here is of course alternate interior angles with that one there, okay? And so I know that angle DAC is congruent to angle BCA. And that's because of alternate interior angles. And notice that this step has to come after this step, because we have to first show that it's parallel, then we can show that alternate interior angles are congruent, okay? I'm going to go ahead and erase this number 4 really fast, because we actually do have one more, because we had to show that line was parallel, we have one more step. So 4, so we have also this side here that is equal to itself. It belongs in both triangles. So AC is equal to itself. AC is congruent to AC, and that's that reflexive property you're going to watch for, okay? When you have the same segment or same angle that's equal to itself, it's a reflexive property, okay? So here we have one part of my triangle that's congruent. I have a second part that kind of flowed from this parallel lines, and a third part, okay? 1, 2, 3 pieces. Now that I have those 3 pieces, I can come up here. I have 2 sides and an angle over here, 2 sides and an angle over here. I think they're congruent, but what I have to really make sure is that my letters all correspond, okay? So what I like to do is do a roadmap. I'm going to start over here at angle B, where there's no really marks. I'm going to follow along the single hashtag, so BCA. So the triangle BCA is congruent to triangle, and I'm going to come over here again where there's no hashes on the other side. Follow along the single hash here, so DAC. And so you have to really pay attention to that, okay? If you can't follow along the same path, then it might not be congruent. So B goes along the single hash to this congruent angle down here. D goes along the single hash to the congruent angle over here, okay? And that reason is going to be my side angle side. Okay, and that is our proof. Okay, so we have our 3 pieces of our triangle, and then our triangle is congruent. Okay, so let's try another one here. All right, so we have here, we know that AD is congruent to CD. And that is given to us both on the figure and written down. Okay, we know that AB is also congruent to CV. That's also given. Okay, so here's one part, 2 part. Let's see if we can find a 3rd piece. So right here we have BD is again congruent to itself. And I put 3 hashes there because it's not congruent to the other ones that are marked. So I know that BD is congruent to itself, BD. And that is the reflexive property. We're going to use the reflexive property a lot, so make sure you know that one, okay? So I have my 3 pieces. Now I can look and I say, oh, it's side, side, side. So I just have to make sure I name them properly, okay? So if I start with A and go along with 2 hash D to B, so I can go here, here's my 4 steps, my triangle, A, D, B would be congruent to triangle. And if I'm going to start over here with C and go to the 2 hash and the 3 hash, so C, D, B. So make sure you have those in order, and that's going to be side, 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 congruent conjecture. Okay, and that's it. All there's to it. 3 pieces and then the triangle. So let's try one more. Okay, so here we want to prove that WFL is congruent to triangle WYL. They have markings over here on the figure, so I'm going to show that angle F is congruent to angle Y. Angle F is congruent to angle Y. And that's going to be given. We also know that LY here is congruent to FL. That is also given. Now I have to try to find that 3rd piece here, okay? So I can see that this piece right here is congruent to itself, right? So we got 1, we got 2, 3, WL is congruent to itself, WL, and that is my reflexive property. Sorry, I can't write very good on this. And then I want to try to show that my triangles are congruent. So let's see. If we start with W and go LY, okay, WLY congruent to triangle WLF. And what reason do we have here? Well, we have an angle and my 2 sides. My angle is not between my 2 sides, right? My 2 sides, my angle is not to them. And that is the SSA or ASS, which we cannot use, right? That is not proof congruence. So this cannot be determined after all that, okay? So this triangle, it might be congruent, but we cannot prove that it's congruent. So make sure you watch out for that. Sometimes people will go all the way through these proofs and then get to the point where it's not determinable, okay? So there you go. You have your assignment in 4.4 in Google Classroom, 4.4 day 2. Don't use SSA, no ass in class, right? It's a Google Slides activity and you should have some fun with it, all right? Thanks so much and have a good night.